Have you ever looked up at the night sky and felt small? What if I told you that feeling small is actually the most comforting realization you could ever have? Here's something that will immediately change how you think about your place in the universe. Right now, as you're watching this video, you're riding on a cosmic carousel, moving at 514,000 miles per hour through space, and yet everything feels perfectly still. The Milky Way galaxy isn't just spinning. It's orchestrating the most peaceful cosmic dance that's been going on for 13.6 billion years, and you're part of it. But here's the shocking part that nobody tells you. The very forces that could tear galaxies apart are the same forces keeping you safely tucked into the most comfortable corner of the universe. Tonight, I'm going to share with you the most soothing secrets about galaxies that will fundamentally change how you fall asleep. Because once you understand what's really happening out there in the vast darkness of space, you'll realize that the universe has been rocking you to sleep since the moment you were born. Before we dive into this cosmic lullaby, do me a favor, hit that like button and subscribe to this channel, because we're about to embark on a 3.5-hour journey through the most peaceful corners of the universe. And I'm genuinely curious. Drop a comment right now telling me what country you're watching from and what time it is there. Are you watching this at 2 a.m., unable to sleep? At sunset, winding down your day? Let me know, because this community spans the entire globe, and I love knowing we're all connected under the same cosmic blanket of stars. Let's start with something that seems impossible: silence. You think space is silent because there's no air to carry sound waves, right? You're partially correct, but here's what will blow your mind: galaxies hum. In 2003, astronomers at NASA discovered something extraordinary using the Chandra X-ray Observatory. They found that the supermassive black hole at the center of the Perseus galaxy cluster has been singing the same note for 2.5 billion years. It's a B-flat, 57 octaves below middle C, a note so low that human ears couldn't hear it, even if we could survive in space. Think of it like this. If the lowest note on a piano is the floor of a building, this galactic hum is coming from a basement 57 floors underground. Dr. Andrew Fabian, the astrophysicist who led this discovery, called it the deepest note in the universe. But here's the truly relaxing part. This isn't chaos. It's rhythm. It's the universe's version of a white noise machine, and it's been playing since before Earth even existed. Now, let me ask you something that might seem strange. What if everything you think is vast and terrifying about space is actually intimate and protective? The Milky Way galaxy contains somewhere between 100 and 400 billion stars. That number is so large, it's meaningless to our brains, right? But here's how to think about it differently. Imagine each star is a house in a neighborhood. The Milky Way isn't some cold, impersonal void. It's the largest gated community in existence, and every single one of those stars is a home to potentially trillions of planets, moons, and cosmic structures. You're not floating in an empty, hostile universe. You're living in the most densely populated cosmic suburb imaginable, and your galactic neighbors are so numerous that if you tried to visit just one star per second, it would take you over 3,000 years to visit them all. The astronomer Carl Sagan once said we're made of star stuff, but he didn't emphasize enough how that makes us family members in the largest extended family reunion that's ever existed. Here's something even more comforting that scientists have only recently understood. Galaxies aren't just random collections of stars. They're organized. In 2019, Dr. Neda Bakal at Princeton University published research showing that galaxies cluster together in what she calls cosmic threads, or cosmic webs. Picture a three-dimensional spider web stretching across hundreds of millions of light years, and at each intersection point, there's a galaxy or a cluster of galaxies. The Milky Way sits comfortably in what's called the local group, which includes about 54 galaxies all gravitationally bound to each other. Think of it like this. If the universe is an ocean, galaxies aren't just random drops of water. They're carefully arranged beads on an invisible cosmic necklace. You're not adrift. You're exactly where you belong, in a structure so organized that it would make the most meticulous architect weep with joy. But let's address the elephant in the room, or should I say, the upcoming collision in the cosmic neighborhood. You might have heard that the Andromeda Galaxy is heading toward the Milky Way at 250,000 miles per hour, and in about 4.5 billion years, they're going to collide. That sounds terrifying, doesn't it? Here's what will completely change your perspective. When galaxies collide, stars almost never actually hit each other. Dr. John Dubinsky at the University of Toronto created computer simulations of the Milky Way Andromeda collision. And here's what he found. The space between stars is so vast that during this collision, the stars will simply pass by each other like two swarms of bees flying through each other. The probability of our sun colliding with another star during this event? Less than 1 in a trillion. Think of it like this. If you shrank the sun down to the size of a grain of sand, the nearest star would be another grain of sand 4 miles away. Now imagine trying to make those 2 grains of sand hit each other. That's why galactic collisions are less like car crashes and more like 2 clouds slowly merging together on a peaceful summer day. Even the most dramatic event in our galactic future is gentle by nature. Here's where things get even more soothing, and I promise this will change how you think about safety forever. The Milky Way has something called the galactic habitable zone, a specific region where conditions are just right for life. We're not randomly placed in our galaxy. Earth sits in what astronomers call the Goldilocks zone of the Milky Way, about 26,000 light-years from the galactic center. In 2001, Dr. Guillermo Gonzalez, an astronomer then at the University of Washington, published groundbreaking research showing that this location is incredibly special. Too close to the galactic center, and the radiation from all those densely packed stars would make life impossible. Too far out in the galactic suburbs, and there wouldn't be enough heavy elements to form rocky planets. But right here, where we are, it's perfect. The radiation levels are low, supernovae are rare enough not to threaten us, and there's just enough cosmic recycling of stellar material to create the complex chemistry needed for life. Think of the Milky Way as a massive city, and we live in that perfect neighborhood, far enough from downtown to avoid the noise and chaos, but close enough to benefit from all the resources. The universe didn't just randomly toss us into existence. It placed us with care. Now, let me tell you about something that happens every single night while you sleep. And once you know about it, you'll never feel alone again. Our solar system, along with all the other stars in our neighborhood, is orbiting around the center of the Milky Way. One complete orbit takes about 225 to 250 million years. Astronomers call this a cosmic year or a galactic year. Since Earth formed 4.5 billion years ago, we've only made about 20 trips around the galaxy. Think about that. Dinosaurs lived and died during one tiny fraction of one galactic orbit. Your entire family tree, stretching back to the first humans, exists in the tiniest sliver of our current journey around the galaxy. But here's the deeply comforting part. This orbital motion is incredibly stable. We've been riding this same cosmic carousel for billions of years, and we'll continue riding it for billions more. The forces of gravity that keep us in this orbit are so perfectly balanced that despite moving at 500,000 miles per hour, everything feels completely still. It's like being on the smoothest train ride imaginable, one that never jolts, never stops, and never derails. You can go to sleep tonight knowing that the universe has been successfully piloting this journey for longer than life has existed on Earth. Let me share something with you that neuroscientists have discovered about our brains in vast numbers. When Dr. Vivian Ming studied how humans process information about scale, she found that our brains literally cannot comprehend numbers beyond a certain threshold. We just can't emotionally connect to billions or trillions. Here's what's beautiful about that limitation. It means that the vastness of the galaxy can't actually overwhelm you. Your brain won't let it. Instead, your mind does something remarkable. It finds patterns, makes connections, and creates meaning. When you look up at the night sky, you're not seeing billions of stars that frighten you with their number. You're seeing patterns, constellations, the Milky Way's dusty band, perhaps a planet or two. Your brain is designed to find comfort in the cosmos, not terror. This is why humans throughout history have looked to the stars for guidance, meaning, and peace. We're neurologically wired to find the galaxy relaxing, not threatening. Every culture that's ever existed has gazed at the same galactic structures we see and felt not fear, but wonder and peace. Here's something that might surprise you about darkness. The spaces between stars in a galaxy aren't empty. They're filled with something called the interstellar medium. This is an incredibly thin gas, about 1 atom per cubic centimeter, along with tiny dust particles. In 2012, Dr. Alyssa Goodman at Harvard University published research showing that these dust clouds aren't just passive material. They're stellar nurseries, the cosmic wombs where new stars are born. The Milky Way creates about 7 new stars every single year. Right now, as you're watching this video, somewhere in our galaxy, a new star is beginning to shine for the first time. Think of it like this: the galaxy isn't a static, dead thing. It's alive, constantly renewing itself, constantly creating new lights in the darkness. That darkness you see when you look up at night, it's not absence, it's potential. It's the canvas on which the universe paints new stars. And this process has been happening with such regularity for so long that astronomers can predict it. The galaxy isn't chaotic, it's creative, productive, and incredibly, almost impossibly, consistent. What if I told you that the most massive thing in our galaxy, the supermassive black hole at its center, called Sagittarius A*, is actually one of the most peaceful objects in the universe? I know what you're thinking. Black holes are destructive, terrifying, all-consuming monsters, right? In 2020, Dr. Andrea Ghez at UCLA won the Nobel Prize in Physics for her decades-long study of Sagittarius A*. And here's what she discovered. This black hole, which has a mass of about 4 million times that of our Sun, is actually remarkably calm. It's not constantly devouring everything around it. In fact, it's what astronomers call dormant most of the time. It sits there at the center of our galaxy, like a peaceful anchor, its gravity providing the organizational structure that keeps all 400 billion stars in their orbits. Think of it like the quiet center of a carousel. It's not moving much itself, but it's what allows everything else to move in such beautiful, predictable patterns. Without Sagittarius A*, the Milky Way wouldn't have its elegant spiral structure. This monster at the heart of our galaxy is actually the reason our galactic neighborhood is so stable and peaceful. It's cosmic irony at its finest. The most feared object in the galaxy is actually its guardian. Now, let's talk about something that will fundamentally shift your perspective on loneliness. You might feel alone sometimes, insignificant in the face of the cosmos. But here's what astronomers have discovered that changes everything. Galaxies are social creatures. The Milky Way isn't traveling alone through space. It's part of what's called the local group, which includes the Andromeda Galaxy, the Triangulum Galaxy, and about 51 smaller dwarf galaxies. But here's what gets even more interesting. The local group is itself part of an even larger structure called the Virgo supercluster, which contains about 100 galaxy groups and clusters. Dr. Brent Tully at the University of Hawaii made an even more stunning discovery in 2014. He found that the Virgo supercluster is actually just a small part of an even more massive structure called Laniakea, which means immeasurable heaven in Hawaiian. Laniakea contains 100,000 galaxies, all flowing together through space like water in a cosmic river. Think of it like this. You live in a house on a street, in a neighborhood, in a city, in a state, in a country, in a continent, on a planet, in a solar system, in a galaxy, in a galactic group, in a supercluster, in a supercluster. You're nested in layers upon layers of cosmic community. You are quite literally the opposite of alone. Here's where we need to pause and let something truly profound sink in. Every single atom in your body was forged in the heart of a star that existed billions of years ago. When those ancient stars died in spectacular supernova explosions, they scattered their material across the galaxy, and that material eventually came together to form our solar system, our planet, and you. In 1952, astronomer Fred Hoyle first proposed this theory of stellar nucleosynthesis, and since then, researchers like Dr. Jennifer Johnson at Ohio State University have traced the specific origins of the elements in our bodies. The iron in your blood was created in the core of a dying star at least 4.6 billion years ago. The calcium in your bones was forged in stars that exploded before our solar system even existed. The oxygen you're breathing right now was created in stellar furnaces scattered across the galaxy. You're not just living in the galaxy, you're made from it. You're not observing the cosmos from the outside. You're the cosmos observing itself. Think about that when you're lying in bed tonight, struggling to fall asleep. You're not separate from the peaceful, ancient rhythms of the galaxy. You are those rhythms, even consciousness and form. Your heartbeat is a small echo of the cosmic processes that have been running smoothly for billions of years. Let me tell you about something called galactic rotation curves, because this is where things get beautifully mysterious. In the 1960s and 70s, astronomer Vera Rubin made observations that changed everything we thought we knew about galaxies. She discovered that galaxies don't rotate the way they should, based on the visible matter we can see. Stars at the outer edges of galaxies are moving much faster than physics says they should, so fast that they should be flung out into intergalactic space, yet they're not. The galaxy holds together. This led to the discovery of dark matter, an invisible substance that makes up about 85% of all matter in the universe. Now, you might think invisible matter sounds scary, but here's the perspective shift. Dark matter is essentially the universe's safety net. It's extra gravity that we can't see, holding everything together more tightly than we ever realized. Think of it like this. You're walking on a bridge, and you discover that the bridge has invisible support beams you never knew about, making it 10 times stronger than you thought. That's dark matter. The galaxy isn't barely holding together. Despite the odds, it's actually far more stable and secure than we can even see. The invisible infrastructure of the universe is working over time to keep everything safe and sound. Here's a question that's going to reframe everything. What if motion is actually a form of stillness? This sounds like a paradox, but stay with me. Right now, you're moving at incredible speeds. Earth is rotating at about 1,000 miles per hour at the equator, orbiting the sun at 67,000 miles per hour. The solar system is orbiting the galactic center at 514,000 miles per hour. And the Milky Way itself is moving through space at about 1.3 million miles per hour toward a point astronomers call the Great Attractor. Add all those motions together, and you're moving at, well, over 1 million miles per hour through space. Yet you feel absolutely still. You don't feel dizzy. You don't feel wind. You can set a glass of water on a table, and it doesn't spill. In physics, this is explained by Einstein's principle of relativity. Motion is relative, and if everything around you is moving at the same speed, you don't feel it. But here's the deeper truth. The galaxy is so vast, and its motion so perfectly orchestrated, that even speeds of 1 million miles per hour are calm and gentle when spread across billions of years and trillions of miles. The most violent sounding cosmic processes are actually incredibly gradual and peaceful when you understand the scale. Time in the galaxy moves like honey, thick, slow, sweet, and utterly unhurried. Now we need to talk about something called the cosmic microwave background, because this is going to give you the ultimate perspective on peace and stability. In 1964, Arno Penzias and Robert Wilson accidentally discovered that the entire universe is bathed in a faint microwave radiation left over from the Big Bang. This discovery won them the Nobel Prize. But here's what's truly remarkable about it. The temperature of this cosmic background radiation is 2.7 Kelvin everywhere in the universe. That's about minus 270 degrees Celsius or minus 454 degrees Fahrenheit. And it varies by only the tiniest fractions of a degree from place to place. The universe has been cooling down from the Big Bang for 13.8 billion years, and it's done so with remarkable evenness and consistency. Think of it like this. The universe is a room that's been cooling down from an incredibly hot temperature. And after almost 14 billion years, the temperature is now perfectly even throughout the entire room, with no hot spots or cold spots. The galaxies we see today, including the Milky Way, formed from the tiniest variations in this otherwise perfectly smooth background. The universe's default state isn't chaos, it's uniformity and calm. Chaos and complexity are the exceptions, the interesting little ripples in an otherwise perfectly peaceful cosmic ocean. The violence and drama we sometimes imagine in space are tiny aberrations in a universe that's fundamentally serene. Let's address something that might keep you awake at night, the fear of cosmic catastrophe. What about asteroids, gamma-ray bursts, nearby supernova, or rogue black holes? Here's the truth that astronomers have calculated. The odds of any catastrophic cosmic event affecting Earth in your lifetime are essentially zero. Dr. Katie Mack, an astrophysicist at North Carolina State University, has done extensive work on cosmic risks, and her conclusion is remarkable. The universe is far less dangerous than science fiction makes it seem. The most recent nearby supernova visible to the naked eye was in 1604, over 400 years ago. Gamma-ray bursts are directed in tight beams, and the odds of one being pointed at Earth are infinitesimally small. The nearest black hole to Earth is about 1,600 light-years away, and it's not moving toward us. Think of the galaxy like an enormous, ancient forest. Yes, occasionally a tree falls, but the forest is so vast that you can walk through it for your entire life and never be near a falling tree. The galaxy has been a safe place for life on Earth for over 4 billion years. If it were truly dangerous, we wouldn't be here to worry about it. The very fact that you exist is proof that the galaxy is, on cosmic timescales, remarkably peaceful and life-friendly. Here's something that will give you an entirely new appreciation for patience. Light from the center of the Milky Way takes 26,000 years to reach Earth. That means when you look toward the constellation Sagittarius, where the galactic center is located, you're seeing light that began its journey toward you 26,000 years ago, long before the pyramids were built, before agriculture was invented, before the last ice age. Light from the Andromeda Galaxy, our nearest large galactic neighbor, takes 2.5 million years to reach us. When you look at Andromeda through a telescope or binoculars, you're seeing it as it was when the first human ancestors were just beginning to evolve in Africa. In 2005, Dr. Mario Livio at the Space Telescope Science Institute published research on cosmic timescales, and his work reveals something profound. Urgency doesn't exist on galactic scales. Everything that happens in a galaxy unfolds over millions or billions of years. Stars are born over millennia, live for billions of years, and die over thousands of years. Think of it like watching the world's longest, slowest movie. Nothing happens quickly. There are no sudden jumps or shocking plot twists. It's all gradual, gentle evolution. When you're lying awake at night, anxious about tomorrow or next week or next year, remember this. The galaxy operates on a timescale where 1 million years is barely noticeable. Your problems, your stress, your anxiety, they're real and important to you, but they exist in a context where time moves with infinite patience. The galaxy has all the time in the universe, and in a very real sense, so do you. Let's talk about something called galactic recycling, because this is going to change how you think about endings and beginnings. Nothing in a galaxy is ever truly lost. When a star dies, it doesn't disappear, it explodes or sheds its outer layers, returning all its material to the interstellar medium. That material then becomes part of new clouds of gas and dust, which eventually collapse to form new stars and planets. Dr. Charles Beichmann at NASA's Jet Propulsion Laboratory has studied this cycle extensively, and he estimates that most atoms in the galaxy have been through this cycle multiple times. The atoms in your body have likely been part of multiple different stars before they became part of Earth, and eventually you. Think of the galaxy as having perfect sustainability, a zero-waste policy that's been in effect for 13.6 billion years. Nothing is discarded. Everything is reused. Death isn't an ending in the cosmic sense. It's a transformation, a return to the pool of materials that will create something new. When you feel like something in your life is ending, remember this? In the galaxy's economy, endings are just pauses before new beginnings. The material that makes you will eventually return to the cosmos, but it won't be destroyed. It will become part of new stars, new planets, maybe even new life. You're not just living temporarily in the universe. You're an eternal participant in its endless cycle of creation and recreation. Now, let me share something about galactic seasons that most people never learn. Just as Earth has seasons caused by its tilt, the solar system experiences seasons as it orbits the galaxy. As we move around the galactic center, we pass through different regions of varying star density, different levels of cosmic rays, and different amounts of interstellar dust. Some scientists, like Dr. Nir Shaviv at the Hebrew University of Jerusalem, have proposed that these galactic seasons might have influenced Earth's climate over very long timescales. But here's what's truly soothing about this idea. These seasons last tens of millions of years. They're so slow that no human generation has ever experienced a transition from one galactic season to another. The environment we live in, the cosmic conditions that surround us, are essentially constant on human timescales. Think of it like living in a house where the thermostat is so well controlled that the temperature never varies by more than a fraction of a degree. And even that tiny variation takes millions of years to happen. The galaxy provides the ultimate stable environment. While things on Earth change rapidly, weather, seasons, climate, the galaxy changes so slowly that it's effectively eternal from our perspective. Here's where we need to talk about something philosophers and scientists call the Copernican principle, but I'm going to explain it in a way that's deeply comforting rather than diminishing. In 1543, Copernicus demonstrated that Earth isn't at the center of the universe. Since then, every astronomical discovery has reinforced that we're not in a special location. We're orbiting an average star in a typical spiral galaxy in an unremarkable part of the universe. This is often presented as depressing. We're insignificant. But here's the reframe that changes everything. Being average is the most comfortable place to be. If we were at the center of the galaxy, we'd be bombarded with deadly radiation. If we were at the far outer edges, we'd lack the heavy elements necessary for life. If we were in an elliptical galaxy instead of a spiral, the environment would be far less stable. Dr. Caleb Scharf at Columbia University wrote an entire book about this called The Copernicus Complex. And his thesis is beautiful. Being typical means we're in the most probable, most stable, most tested configuration. Think of it like this. Would you rather live in the absolute center of a major city, or in the far wilderness, or in a comfortable suburb? Being average in cosmic terms means we're in the safest, most stable, most predictable location possible. The universe didn't place us at the edge of existence, barely clinging to survival. It placed us right in the middle of comfort and safety. Let me tell you about galactic time from a different angle, one that involves your own body and experience. Your cells regenerate on different timescales. Stomach lining every few days, skin every few weeks, LIVER cells every few months, bone cells every 7 to 10 years. Over the course of about 7 years, most of the atoms in your body are replaced. You're constantly being renewed, constantly being remade from the food you eat and the air you breathe. But here's the connection to galaxies that will blow your mind. Those replacement atoms came from the galaxy billions of years ago. You're not a fixed, permanent thing. You're a temporary pattern of organization of galactic material. Think of yourself like a whirlpool in a river. The whirlpool has a shape and identity, but the water flowing through it is constantly changing. You're not separate from the flow of the galaxy. You're a beautiful temporary eddy in that flow. This means that on a deep level, the boundary between you and the galaxy is an illusion. Where do you end and the cosmos begin? The answer is, you don't end. You're continuous with everything. And that continuity has been stable for billions of years and will remain stable for billions more. You can rest in that continuity. You can sleep in the knowledge that you're not a fragile, isolated thing, but rather a wave in an ocean that's been gently rolling for longer than time has meaning. Now we're going to talk about something called the Fermi paradox, but I promise I'll make it comforting rather than disturbing. In 1950, physicist Enrico Fermi asked a famous question. If the galaxy is so old and contains so many stars, where are all the aliens? This question has bothered people for decades. But here's a perspective from Dr. Anders Sandberg at Oxford University that's deeply reassuring. The silence of the galaxy might not mean we're alone. It might mean that intelligent life, when it arises, tends toward peace and quiet. Advanced civilizations might have no desire to expand aggressively across the galaxy. They might be perfectly content where they are, living sustainably, exploring their own systems, maybe even sleeping peacefully under their own stars, just like we are. Think of the galaxy not as a dark forest full of hidden predators, but as a peaceful suburban neighborhood where everyone minds their own business, tends their own gardens, and occasionally waves hello, but doesn't intrude. The silence isn't threatening. It's respectful. It's space. It's calm. And if we are alone, or nearly so, then the galaxy is an almost infinite playground awaiting our descendants. Billions of years of cosmic real estate where future humans might eventually spread in their own peaceful, unhurried way. Either way, whether we're surrounded by quiet neighbors or beautifully alone, the galaxy is a peaceful place. Let's talk about cosmic perspective and its effect on human consciousness. In 1972, the Apollo 17 crew took a photograph of Earth from space called the Blue Marble. This image fundamentally changed how humans saw themselves. Psychologists have documented something called the overview effect. When astronauts see Earth from space, they often report a profound cognitive shift, a sense of unity, peace, and interconnectedness. Dr. David Yadin at Johns Hopkins University studies this effect, and he's found that even people who just look at space images regularly report similar feelings of calm and perspective. Here's why. When you zoom out to the galactic scale, all human conflicts become invisible. All borders disappear. All differences in ideology, nationality, religion, or politics shrink to nothing. From the galactic perspective, we're all the same temporary patterns of organized matter, briefly aware, sharing the same tiny blue world in a vast cosmic ocean. Think of it like this. When you're stressed about daily life, you're zoomed in too close. You're looking at individual pixels on a screen. But when you zoom out to the galactic scale, you see the whole picture, and the picture is beautiful. The galaxy gives us the ultimate context for our lives. It doesn't make our lives meaningless. It makes them precious precisely because they're temporary and small. A flower isn't less beautiful because it's small and brief. Your life isn't less meaningful because the galaxy is ancient and vast. In fact, the contrast makes your life more meaningful, not less. Here's something about cosmic numbers that's going to fundamentally change how you think about probability and safety. The galaxy is so large and contains so many stars that almost anything that can happen probably has happened somewhere, sometime. But here's the flip side that nobody talks about. The galaxy is so large that the odds of anything specific happening to you are essentially zero. In 1961, Dr. Frank Drake created an equation to estimate the number of communicating civilizations in the galaxy. While we still don't know the answer, the equation illustrates something important. When you multiply probabilities across billions of stars and billions of years, you get a universe where life is both probably common and definitely separated by vast distances. Think of it like winning the lottery. The odds of someone somewhere winning are pretty good, but the odds of you specifically winning are tiny. You're protected by probability. The sheer size of the galaxy means that you're insulated, buffered, surrounded by empty space that keeps all the dangerous, chaotic, violent processes of stellar evolution far, far away from your comfortable cosmic neighborhood. You live in a protective bubble of probability, where the odds are forever in your favor, where the vastness that seems threatening is actually your shield. Let me tell you about something called cosmic inflation and the early universe, because this will give you a new appreciation for where the peaceful structure of galaxies came from. In the first tiny fraction of a second after the Big Bang, we're talking about 10 to the negative 36 seconds, the universe underwent a period of exponential expansion called inflation. Dr. Alan Guth proposed this theory in 1980, and it's been confirmed by multiple observations since then. During inflation, quantum fluctuations, tiny random variations, were stretched out to cosmic scales. These fluctuations eventually became the seeds of galaxies. Here's what's beautiful about this. The random quantum foam of the early universe was like static on an old TV, but inflation smoothed it out, stretched it, turned it into a pattern. The chaos of the quantum world became the order of the cosmos. Think of it like taking a rough piece of clay and stretching it until it becomes smooth. The galaxy you live in, with all its peaceful structure and regularity, was born from chaos, but shaped by physical laws into something organized and calm. The universe has a built-in mechanism for turning disorder into order, for turning noise into music. And that mechanism has been running perfectly for 13.8 billion years. You're living in the mature, organized, peaceful era of the universe. After the initial chaos of the Big Bang had settled, after stars had formed and created heavy elements, after enough time had passed for stable systems like our solar system to emerge. You're living in the universe's golden age, the long, stable middle period between the violent birth and the far distant future. Now let's talk about the concept of cosmic time dilation, because this is going to give you an entirely new understanding of how time works in the galaxy. Einstein's theory of general relativity tells us that time runs differently depending on gravity and velocity. The stronger the gravity or the faster you're moving, the slower time passes for you relative to an outside observer. Near the supermassive black hole at the center of the galaxy, time runs significantly slower than it does here on Earth. If you could somehow survive near the event horizon of Sagittarius Asterisk, you could watch millions of years pass in the outer galaxy in what felt like days to you. Dr. Kip Thorne explored these ideas extensively, and they won him a Nobel Prize in 2017 for his work on gravitational waves. But here's the comforting application. Time isn't absolute. Your experience of time is unique to you. When you're sleeping, hours pass in what feels like minutes. When you're stressed, minutes feel like hours. On a cosmic scale, time is even more flexible. The galaxy doesn't run on one universal clock. Every location experiences time slightly differently. Think of the galaxy as a place where past, present, and future are all more fluid than we usually imagine. The rigid march of time that makes us anxious doesn't really exist on a cosmic scale. The galaxy is patient because time for the galaxy is abundant to the point of meaninglessness. And that patience, that timelessness, is available to you too when you shift your perspective. When you're lying in bed, unable to sleep, worried about time passing, remember that time itself is flexible, subjective, and on cosmic scales, essentially infinite. Here's something about entropy and the arrow of time that's going to reframe everything. The second law of thermodynamics tells us that entropy disorder always increases over time. This sounds depressing. Everything is falling apart, winding down, heading toward heat death. But Dr. Sean Carroll at Johns Hopkins University has a different take on this. He points out that life itself is a temporary decrease in local entropy. You are an organized, complex structure existing in defiance of entropy. Yes, on the largest scales, the universe is winding down. But on human scales, on planetary scales, on stellar scales, complexity is increasing. Stars are forming, planets are coalescing, life is emerging. The galaxy isn't dying, it's creating. Think of entropy like this. Yes, eventually the party will end, but right now, the party is in full swing. The band is playing, people are dancing, new guests keep arriving, and there's no indication the party will end anytime in the next trillion years. The heat death of the universe is so far in the future that it's meaningless to your life, to Earth's life, even to the sun's life. You're living in the era of creation, not the era of decay. The galaxy is young and vibrant, even though it's billions of years old, because the timescales are so vast that old and young lose meaning. The peaceful structure of galaxies isn't a temporary aberration in a universe of chaos. It's the natural state of the universe during its long, productive middle age. Let me share something about cosmic rays and magnetic fields that illustrates how protected we are. Cosmic rays are high-energy particles that fly through space at nearly the speed of light. They're created by supernova, black holes, and other violent cosmic events. If these particles reached Earth's surface at full strength, they'd be deadly to life. But here's the beautiful part. We're protected by multiple layers of defense. The galaxy has a magnetic field that deflects many cosmic rays. The sun has a magnetic field that deflects more. The Earth has its own magnetic field, the magnetosphere that deflects even more. And our atmosphere absorbs what's left. Dr. Eugene Parker, for whom NASA's Parker Solar Probe is named, spent decades studying these protective fields, and his work shows just how well insulated we are from cosmic dangers. Think of yourself as living inside a series of nested force fields, each one filtering out harm, each one maintained by natural processes that have been stable for billions of years. You're not exposed to the dangers of space, you're cradled within layer after layer of protection. The galaxy isn't a hostile environment that we've barely managed to survive in. It's a place where the physics naturally creates protective structures, where magnetic fields arise automatically from rotating charges, where atmospheres form around planets, where life emerges not despite the cosmos, but because of it. Here's where we need to talk about something called the anthropic principle, and I'm going to explain why it's comforting rather than confusing. The anthropic principle, in its simplest form, says that we observe the universe to have properties compatible with our existence, because if it didn't have those properties, we wouldn't be here to observe it. This sounds circular, but here's the profound implication. The universe doesn't need to try to create life. The very fact that we exist to ask questions about the universe means that we're living in one of the possible universes where asking questions is possible. Dr. Brandon Carter proposed this principle in 1973, and it's been refined since then. Think of it like this. Imagine a trillion different possible universes with different physical laws. In most of them, stars can't form, or atoms can't exist, or complexity can't arise. But we don't live in one of those universes. We live in a universe and a galaxy where the constants of physics are just right for stars, for planets, for chemistry, for life. You can stop worrying about whether the universe is supposed to be the way it is. It is the way it is, and the way it is happens to be conducive to peaceful galaxies and comfortable planets and beings who can lie in bed at night contemplating the cosmos. You're not an accident that's barely clinging to existence in a hostile universe. You're an inevitable outcome of a universe whose properties make beings like you not only possible, but probable. Now, let's talk about something called the cosmological principle, which states that the universe is homogeneous and isotropic, meaning it's basically the same everywhere and looks the same in all directions. This principle was proposed in the early 20th century and has been confirmed by observations of the cosmic microwave background and the distribution of galaxies. Here's why this matters for your peace of mind. There's nowhere in the galaxy that's fundamentally different from anywhere else. There's no dangerous edge of the universe we need to avoid. There's no cosmic cliff we might fall off. Everything everywhere is governed by the same physical laws, has the same fundamental properties, and evolves in the same basic ways. Think of the universe as an infinite quilt where every patch is made from the same material and pattern. No matter where you are or where you go, the same rules apply, the same safety measures are in place, the same gentle processes are unfolding. There are no hidden surprises, no undiscovered dangers lurking in some unmapped corner of space. The galaxy is predictable, knowable, and uniform in its fundamental properties. You can relax into the sameness of it all, the reliable consistency that pervades every corner of cosmic space. Let me tell you about stellar lifespans and why they're relevant to sleep. Our sun is about 4.6 billion years old, and it has about another 5 billion years before it runs out of hydrogen fuel and begins to die. That's a time span so long that all of human civilization, from the first cities to today, represents only 0.002% of the sun's lifetime so far. Dr. Gregory Laughlin at Yale University has studied stellar evolution extensively, and his work shows that stars like our sun are incredibly stable during their main sequence lifetime. The sun's output varies by less than 0.1% over centuries. Think about that level of reliability. The most important star in your sky, the one that provides all the energy for life on Earth, has been burning steadily, with almost no variation, for longer than multicellular life has existed. And it will continue to burn steadily for time spans so long that the human mind cannot grasp them. When you worry about tomorrow, about next month, about next year, remember that the sun has been rising every morning for 4.6 billion years and will continue to rise every morning for 5 billion more. That's the level of reliability and stability that the galaxy operates on. Your problems, no matter how serious they feel, exist within a context of cosmic stability that's essentially eternal from a human perspective. Here's something about the speed of light that's going to change how you think about cosmic communication. Light travels at 186,282 miles per second, the fastest speed possible in our universe. Even at this incredible speed, it takes years for light to travel between stars. The nearest star to our sun, Proxima Centauri, is 4.24 light-years away. This sounds like it makes the universe lonely, but here's the reframe. The speed of light creates a buffer zone around every solar system. It's a natural quarantine that ensures nothing can reach you quickly. If something dangerous were happening at the nearest star, we wouldn't know about it for over 4 years. And even if something were traveling toward us at nearly the speed of light from there, it would still take over 4 years to arrive. We'd have warning. We'd have time. Dr. Lawrence Krauss has written extensively about cosmic distances, and his work emphasizes how protected we are by the sheer vastness of space combined with the universal speed limit. Think of the speed of light not as a limitation, but as a protective speed limit on the cosmic highway. Nothing can rush at you. Everything that happens in the galaxy happens slowly enough that if it were going to affect you, you'd have advance warning measured in years or decades or millennia. The galaxy operates at a pace that allows for contemplation, preparation, and peaceful response. There's no such thing as a cosmic surprise attack, because distance and the speed of light ensure that everything comes with plenty of advance notice. Now let's address something that might seem dark, but actually contains a beautiful truth: the eventual fate of galaxies. Over trillions of years, galaxies will slowly run out of gas to form new stars. Existing stars will age and die. The universe will become dark and cold. This is often called the heat death of the universe. But here's what Dr. Katie Mack emphasizes in her work. This fate is so far in the future that it's essentially irrelevant to anything happening now. By the time the last stars begin to flicker out, Humans, if we still exist, will have evolved into something unrecognizable. We'll have had trillions of years to adapt, to create, to explore, to become something new. Think of the universe like a story. Yes, every story ends, but that doesn't make the story meaningless. The fact that a book has a final page doesn't make the book worthless. The galaxy's eventual fate doesn't diminish the beauty of its current existence. If anything, the temporary nature of everything makes it more precious, not less. You can sleep peacefully tonight, knowing that while nothing lasts forever on cosmic scales, everything lasts more than long enough on human scales. The sun will shine for longer than you can imagine. The galaxy will continue its majestic rotation for periods of time that dwarf all of human history. The ending is so far away that it might as well not exist at all. Let me share something about galactic archaeology that's going to give you a sense of deep history and continuity. By studying the chemical composition of stars, astronomers can determine when different stars formed and what generation of stellar recycling they came from. The oldest stars in our galaxy formed over 13 billion years ago from nearly pure hydrogen and helium. Stars like our Sun, which contain heavier elements, are younger third or fourth generation stars born from the ashes of previous stellar generations. Dr. Anna Frebel at MIT is one of the leading researchers in this field, and her work has identified some of the oldest stars still shining in our galaxy. Here's what's beautiful about this. The galaxy has a memory. Its history is written in the light of its stars. Just as geologists can read Earth's history in rock layers, astronomers can read the galaxy's history in stellar populations. And that history shows continuity, gradual change, and patient evolution over timescales that make all human concerns fade into insignificance. Think of the galaxy as an ancient library, where every star is a book, and together they tell the complete story of cosmic evolution from the beginning of time to now. You're not living in a chaotic, random universe. You're living in a place with deep history, with causes and effects stretching back to the beginning of time, with every generation of stars building on the work of previous generations. There's a narrative arc to the cosmos, and you're part of the current chapter. Here's something about orbital mechanics that illustrates the inherent stability of galaxies. When a satellite orbits Earth, it's not being held up by anything. It's actually falling toward Earth, but moving sideways fast enough that it keeps missing. This is called orbital motion, and it's inherently stable. Once something is in orbit, it will stay in orbit unless disturbed by outside forces. The same principle applies to everything in a galaxy. Every star, every planet, every cloud of gas is in orbit around the galactic center, and these orbits are stable over billions of years. Dr. Jerry Ostraker at Columbia University has studied galactic dynamics for decades, and his work shows just how resistant galactic structures are to disruption. Even when galaxies collide, the individual stars mostly just settle into new stable orbits around the combined center of mass. Think of orbital motion as the universe's way of creating permanent structure without any support beams, without any foundation, without anything holding things up. Gravity and motion combine to create stable configurations that can last essentially forever. The galaxy doesn't need maintenance. It doesn't need anyone to keep it running. The laws of physics ensure that once a galaxy forms, it will continue existing, orbiting, evolving gracefully for time spans that dwarf all of recorded history. You're not living in a precarious structure that might collapse. You're living in a configuration that's guaranteed to remain stable for longer than you can possibly worry about. Let's talk about what astronomers call the fine structure constant and why it's one of the most comforting things in physics. This constant, denoted by the Greek letter alpha, describes the strength of electromagnetic interactions. It's approximately 1/137th. And here's what's amazing. If this number were even slightly different, atoms couldn't form, chemistry wouldn't work, and life couldn't exist. Dr. John Barrow at Cambridge University spent years studying this and other fundamental constants. And his conclusion is striking. The constants of nature appear to be fine-tuned to allow complexity. Now, physicists debate whether this fine-tuning implies design or is just selection bias. We exist in a universe where these constants allow life, because if they didn't, we wouldn't be here to notice. But regardless of the explanation, the fact remains. The universe is set up in a way that allows for stable atoms, complex chemistry, and ultimately, you. Think of the universe as a musical instrument that's perfectly in tune. Not slightly out of tune, perfectly in tune. Every string is at exactly the right tension. Every drum head at exactly the right tightness. Every reed at exactly the right stiffness. The cosmic symphony plays in perfect harmony, not because someone is constantly adjusting it, but because the instrument itself is built right. You're living in a universe where the fundamental parameters allow for the most beautiful music, and that music has been playing in perfect key for nearly 14 billion years. Now here's something about the concept of cosmic horizons that's going to reframe how you think about boundaries and limits. Due to the expansion of the universe, there's a limit to how far we can see. It's called the cosmic light horizon, and it's about 46 billion light years away in all directions. Beyond that distance, light hasn't had time to reach us since the Big Bang, so we can't see what's there. Some people find this disturbing. There are parts of the universe we can never see or reach. But here's the reframe. This horizon means you're living in a cozy, bounded region of space. You're not exposed to the entire infinite universe. You have a defined neighborhood, a comfortable bubble of observability within which everything is knowable and nothing is inaccessibly distant. Think of it like living in a house with walls. Yes, there's a world outside you can't see, but the walls create a sense of comfort, privacy, and defined space. The cosmic horizon does the same thing on a universal scale. You're not drowning in infinity. You're cozily tucked into a 93 billion light-year wide bubble of observable space, and everything within that bubble is governed by the same laws, evolving in the same ways, and fundamentally knowable. The universe has built-in boundaries that prevent you from being overwhelmed by infinite complexity. Let me tell you about something called the galactic habitable zone theory, which we touched on earlier but deserves deeper exploration. Developed by Dr. Guillermo Gonzalez and others, this theory proposes that only certain regions of a galaxy are suitable for complex life. Too close to the galactic center, too much radiation, too many supernova, too much gravitational chaos. Too far out, not enough heavy elements to form rocky planets. But in the middle, in a ring-shaped zone about 13,000 to 33,000 light-years from the galactic center, conditions are just right. Earth sits at about 26,000 light-years from the center right in the middle of this habitable zone. But here's what's truly remarkable. This zone is absolutely enormous. It contains billions of stars. You're not living in some precarious edge case barely suitable for life. You're living in the middle of a vast region that's optimized for stability, safety, and complexity. Think of the galaxy as a massive apartment building, and the habitable zone is the entire middle 10 floors, far from the noisy ground floor, far from the unstable penthouse, right in the safe, quiet, comfortable middle. And you're not alone on these floors. There are potentially billions of other solar systems in this same comfortable zone. You're living in the best possible neighborhood in the galaxy, and that neighborhood is enormous. Here's something about cosmic recycling that adds another layer to what we discussed earlier. When you breathe out carbon dioxide, that carbon will eventually be absorbed by plants, which will be eaten by animals, which will die and decompose, returning the carbon to the soil or atmosphere. This cycle happens on Earth over years and decades. But there's a much larger cycle too. Eventually, billions of years from now, the sun will expand into a red giant, engulf Earth, and the atoms that make up your body right now will be blasted out into space. Those atoms will become part of a new generation of stars and planets. Dr. Michelle Thaler at NASA's Goddard Space Flight Center has beautifully described this cosmic recycling. We are not separate from the universe. We are how the universe knows itself. Your atoms have been through this cycle before. They were part of previous stars, previous planets, perhaps even previous forms of life. And they'll continue this cycle long after you're gone. Think of yourself not as a fixed, permanent self, but as a temporary pattern in an eternal flow. You're a wave in an ocean, a whirlpool in a river, a song being sung by atoms that have been singing for billions of years. This isn't depressing, it's liberating. You're part of something that never truly ends, only transforms. When you sleep tonight, rest in the knowledge that the atoms that make you our ancient have been through countless forms and will continue their journey long after your particular pattern has dissolved back into the cosmos. Now let's talk about galactic navigation and why the stability of the stars is so comforting. For thousands of years, humans have used stars for navigation. The North Star, Polaris, has been guiding travelers because it stays in the same apparent position as Earth rotates. But here's what's remarkable. Due to the slow wobble of Earth's axis called precession, Polaris won't always be the North Star. In about 12,000 years, the star Vega will be the pole star instead. This cycle takes about 26,000 years, one complete precession cycle. Dr. Bradley Schaefer at Louisiana State University has studied historical star catalogs and shown just how stable stellar positions are over human timescales. The stars are so far away that even though they're moving, sometimes at hundreds of kilometers per second, their positions appear fixed over multiple human lifetimes. Think of the stars as the universe's reference points, cosmic lighthouses that maintain their positions with such reliability that you can navigate by them not just over a single lifetime, but over multiple generations. The sky your great-great-grandparents saw is essentially the same sky you see, and the sky your great-great-grandchildren will see will be essentially the same. This stability, this reliability, this utterly dependable consistency of the heavens is one of the most comforting features of living in a galaxy. You can always look up and know where you are. The cosmos provides permanent, reliable reference points that never fail, never drift, never disappear without warning. Here's something about gravitational waves that illustrates how gentle the universe actually is despite containing such massive objects. In 2015, LIGO, the Laser Interferometer Gravitational Wave Observatory, detected gravitational waves for the first time, ripples in spacetime caused by two black holes colliding 1.3 billion light-years away. This discovery won Rainer Weiss, Kip Thorne, and Barry Barish the Nobel Prize in 2017. But here's what's astonishing. These were two black holes, each about 30 times the mass of the Sun, colliding with each other at a significant fraction of the speed of light. And the gravitational wave they produced was so weak that by the time it reached Earth, it changed the length of LIGO's 4-kilometer arms by less than 1/10,000th the diameter of a proton. Think about that. The most violent events in the universe, black hole collisions, produce disturbances so small that even with the most sensitive instruments humanity has ever built, we can barely detect them. The universe insulates you from violence. Even the most powerful explosions, the most energetic collisions, the most catastrophic events are dampened by distance until they're essentially undetectable. You're living in a universe where even cataclysms become gentle whispers by the time they reach you. The galaxy is so vast that it absorbs violence, dilutes chaos, and delivers only the faintest echoes of distant drama. Let me share something about the concept of cosmic pessimism versus cosmic optimism. Some philosophers, looking at the vast emptiness of space and the eventual heat death of the universe, conclude that everything is meaningless. But Dr. Brian Greene at Columbia University offers a different perspective in his work. He points out that meaning isn't given by the universe. It's created by conscious beings like us. The galaxy doesn't need to provide your life with meaning. You provide your life with meaning through your choices, relationships, creations, and experiences. The galaxy provides something else: context, beauty, and an environment stable enough for meaning-making to be possible. Think of the galaxy as a stage. The stage doesn't write the play, but without the stage, the play couldn't be performed. The galaxy is the stable, reliable, ancient stage on which the drama of your life plays out. And unlike a physical stage, this cosmic stage has been standing for billions of years and will continue standing for billions more. You're not performing on a rickety temporary platform that might collapse. You're performing on the most solid, enduring foundation that's ever existed. The galaxy doesn't give your life meaning, but it provides the stable framework within which you can create meaning for yourself. And that framework is so reliable that you never need to worry about it failing. Here's something about the density of the galaxy that's going to surprise you. Despite containing hundreds of billions of stars, the galaxy is mostly empty space. In fact, space is so empty that if you were to randomly place yourself somewhere in the galaxy, the odds that you'd be within a few million miles of anything at all, any star, planet, or even asteroid, are virtually zero. Dr. Robert Nemiroff at Michigan Technological University calculated that the average density of our galaxy is about 1 hydrogen atom per 4 cubic centimeters. That's emptier than the best laboratory vacuum we can create on Earth. Think of the galaxy not as a crowded place, but as the ultimate in spacious, open-plan living. You have more elbow room than you could ever possibly use. The galaxy is like living in a nature preserve, where your nearest neighbor is 100 miles away, and there's nothing but peaceful wilderness in between. This emptiness isn't lonely, it's luxurious. It's space to breathe, space to exist, space to be yourself, without anything crowding you or pressing in on you. The galaxy gives you room. So much room that you'll never run out of it. Now let's talk about something called stellar metallicity and why it shows the galaxy is getting more hospitable to life over time. When the universe first formed, it contained only hydrogen, helium, and trace amounts of lithium. These light elements can't form the complex chemistry necessary for life. But stars act as fusion reactors, combining light elements into heavier ones. When stars die, they release these heavier elements, what astronomers call metals, even though they include elements like carbon, oxygen, and nitrogen, not just metallic elements. Each generation of stars adds more metals to the galaxy. Dr. Ken Freeman at the Australian National University has studied how the galaxy's metallicity has increased over time. And his work shows that our solar system formed at a time when the galaxy had enough metals to create rocky planets and support complex chemistry. We're living in the first cosmic era where planets like Earth are even possible. Think of the galaxy as maturing over time, slowly becoming more complex, more interesting, more conducive to life. You're not living in a young, chaotic galaxy or an old, dying galaxy. You're living in the galaxy's prime, old enough to have accumulated the necessary ingredients for life, young enough to still be actively creating new stars and systems. The galaxy had to age billions of years before it was ready for beings like you, and it succeeded. You're the product of cosmic evolution, the result of the galaxy slowly perfecting the recipe for complexity over 13 billion years of cosmic cooking. Here's something about the shape of galaxies that illustrates inherent order in the cosmos. Galaxies come in a few basic types: spirals like the Milky Way, ellipticals, and irregulars. But here's what's fascinating. About 70% of galaxies are spirals or ellipticals, organized, symmetrical shapes. Only about 30% are irregular, and even those irregulars often show structure if you look closely. Dr. Edwin Hubble created the first galaxy classification system in 1926, and it's still used today because galaxies fall into such clear categories. Here's why this matters. The universe has an organizing principle. Random chaos would produce random shapes, but instead, we see patterns, symmetry, and structure. Think of galaxies like snowflakes. Each one is unique in its details, but they all follow the same basic patterns because they're governed by the same underlying rules. The galaxy isn't a random accident. It's a structured, organized system that formed according to the laws of physics. and those laws naturally produce order, beauty, and symmetry. When you look at images of galaxies, you're seeing the visible manifestation of mathematical laws that have been operating consistently for billions of years. The universe is mathematical, orderly, and predictable at its core. That predictability is your cosmic safety net. Let me tell you about something called the Sagittarius Dwarf Elliptical Galaxy. This is a small galaxy that's currently being absorbed by the Milky Way. It's been orbiting our galaxy and passing through the Milky Way's disk multiple times over the past few billion years. Each time it passes through, it loses some of its stars to the Milky Way's gravity. Eventually, it will be completely absorbed, its stars becoming part of the Milky Way. This sounds violent, but here's the reality. Dr. Rodrigo Ibarra discovered this galaxy in 1994, and subsequent studies have shown that this absorption process is incredibly gentle. Stars from the Sagittarius galaxy simply join the general population of Milky Way stars. They don't collide with anything. They don't explode. They just peacefully integrate into a larger system. Think of it like a small stream joining a large river. The water from the stream doesn't violently crash into the river. It simply merges, becomes part of the larger flow, and continues on its journey. The galaxy is absorbing smaller galaxies all the time, but doing so in a way that doesn't disrupt anything. Even galactic cannibalism is gentle in the cosmos. The gravitational forces that could theoretically tear things apart instead orchestrate peaceful mergers over hundreds of millions of years. Violence doesn't scale up in the galaxy, it scales down. The bigger the system, the gentler the processes. Here's something about cosmic distances that creates a natural shield around us. The nearest potentially hazardous star to our solar system is IK Pegasi, a binary star system about 150 light-years away. One of the stars in that system is a white dwarf that could potentially go supernova someday. But even if it did, at 150 light-years away, the radiation would be significantly weakened before reaching Earth. Dr. Adrian Nullett at the University of Kansas has studied supernova effects on Earth, and his research shows that a supernova would need to occur within about 25 light-years to pose a real threat to life on Earth. Within that danger zone, there are no stars likely to go supernova anytime soon. The nearest candidate, Betelgeuse, is about 550 light-years away, more than 20 times farther than the danger zone. Think of yourself as living in a protective bubble with a radius of 25 light-years. Within that bubble, there are no cosmic threats. Outside that bubble, there are potential threats, but they're all far enough away that even their most violent acts can't harm you. The galaxy has naturally arranged things so that the dangerous stars are far away and the nearby stars are safe. It's like living in a neighborhood where all the fireworks factories are on the other side of town. You can see the pretty lights, but you're far enough away that you're never in danger from the explosions. Now let's talk about the concept of cosmic hierarchy and why it's stabilizing. The universe is organized in nested structures. Atoms form molecules, molecules form cells, cells form organisms, organisms form ecosystems, ecosystems exist on planets, planets orbit stars, stars cluster in galaxies, galaxies cluster in groups, groups cluster in superclusters. Each level of organization is stable within its own right and contributes to the stability of the level above it. Dr. Philip James Edwin Peebles won the Nobel Prize in 2019 for his theoretical discoveries in physical cosmology, particularly regarding the large-scale structure of the universe. His work shows that this hierarchical organization isn't random. It's the natural result of gravity operating over cosmic time. Think of the universe as a perfectly organized company with clear management structure, clear reporting lines, and clear divisions of labor. Nothing is chaotic. Everything has its place and function. Atoms don't need to worry about galactic dynamics, and galaxies don't interact with individual atoms. Each level operates independently, according to its own rules, and yet all the levels work together to create a stable, functional whole. You exist in the middle of this hierarchy, large enough to be affected by atomic and molecular processes, small enough to be affected by planetary and solar processes, but completely insulated from both the quantum chaos at the smallest scales and the cosmic evolution at the largest scales. You live in the sweet spot of the cosmic hierarchy, where everything is stable, predictable, and comprehensible. Let me share something about cosmic background light that illustrates how filled the universe is, even though space seems empty. When you look at a dark patch of sky with no visible stars, you might think you're looking at nothing. But in 2020, Dr. Todd Lauer at the NSF's OIR lab led a study using data from the New Horizons spacecraft to measure something called the cosmic optical background. They found that there's a faint, diffuse glow filling all of space light from distant galaxies so far away they're not individually visible, but collectively they create a background glow. Think of it like this. When you're in a city at night, the sky is never truly dark because of light pollution from thousands of streetlights. Similarly, space is never truly dark because of cosmic light pollution from billions of galaxies. You're not surrounded by emptiness. You're surrounded by ancient light that's been traveling for billions of years. Light from galaxies so distant that they existed when the universe was young. Light that's so dim, you need the most sensitive instruments to detect it. But light nonetheless. The universe is luminous. Even in the darkest corners, there's a gentle glow. A reminder that you're never truly in darkness, because the combined light of billions of galaxies fills every corner of space. Here's something about the Milky Way's rotation curve that shows how gravitational systems self-stabilize. When astronomers measure how fast stars orbit the galactic center at different distances, they expect to find that stars farther out move slower, just like planets farther from the sun move slower. But that's not what Vera Rubin found. She discovered that stars at the outer edges of galaxies move at roughly the same speed as stars closer in. This was one of the first pieces of evidence for dark matter, which I mentioned earlier. But here's the deeper implication. Galaxies have more mass than we can see, and that mass creates a gravitational field that keeps everything stable. The galaxy is more massive than it appears, which means it's more gravitationally bound, more stable, more resistant to disruption than we initially thought. Think of it like finding out your house has a foundation twice as deep and twice as strong as you realized. You were already safe, but now you're even safer. The invisible dark matter that surrounds and permeates the galaxy is providing extra gravitational glue, holding everything together more tightly than visible matter alone could. You're living in a galaxy that's over-engineered for stability. It has redundant safety systems. It's built to last not just billions of years, but trillions. Let's talk about the concept of cosmic evolution and why it shows that the universe is heading toward complexity, not simplicity. Yes, entropy increases, but in localized regions where there's available energy like inside stars, or on planets heated by stars' complexity can increase. Life itself is an example of increasing complexity, a local decrease in entropy paid for by the entropy increase happening in the sun. Dr. Eric Chasen at Harvard has studied what he calls cosmic evolution, the progression from simple to complex structures throughout the history of the universe. His work shows that complexity has been increasing steadily, from hydrogen atoms to complex molecules, from simple chemistry to self-replicating molecules, from single cells to multicellular life, from simple organisms to complex ones with brains and consciousness. Think of the universe as a story that's becoming more interesting as it unfolds. The early universe was simple, just hydrogen and helium, no stars, no planets, no structure. But over time, the universe has become more complex, more interesting, more rich with structure and pattern. And you're part of the most complex structures the universe has yet produced conscious beings capable of understanding the cosmos. The galaxy isn't winding down into simplicity. It's building up toward greater and greater complexity. and you're at the leading edge of that process. The future of the galaxy will be more complex than its past, not less, at least for trillions of years to come. Here's something about the solar system's location in the galaxy that shows how carefully protected we are. We don't just orbit the galactic center, we also move up and down through the galactic disk. This motion takes about 64 million years to complete one oscillation. Dr. Richard Muller at UC Berkeley proposed that this oscillation might correlate with mass extinction events on Earth, though this theory remains controversial. But here's what's not controversial. For most of our oscillation period, we're above or below the densest part of the galactic disk, which means we're exposed to less cosmic radiation, fewer gravitational perturbations, and less risk from supernova. Think of the solar system as being on a slow-motion roller coaster, rising and falling through the galaxy's disk. Most of the time, we're in the safe zones above or below the busiest part of the galaxy. Even when we pass through the disk, we're moving through a region that's already relatively safe because of our location in the galactic habitable zone. We're protected by multiple layers of safety: the right distance from the galactic center, the right chemical composition of our neighborhood, and now we can add the right phase of our vertical oscillation. The galaxy has positioned us in the safest possible location in multiple dimensions simultaneously. This isn't luck, this is selection effect. Life can only observe the universe from places where life can exist, and those places are, by definition, extraordinarily safe. Now let me tell you about something called the Great Attractor, because it sounds scary, but it's actually fascinating and ultimately comforting. The Great Attractor is a gravitational anomaly in intergalactic space at the center of the local Laniakea supercluster. Everything in our region of space, including the Milky Way, is slowly moving toward it. Dr. Brent Tully discovered this in the 1980s, and it sounds like we're being pulled towards something dangerous. But here's the reality. The Great Attractor is about 150 to 250 million light years away, and we're moving toward it at about 600 kilometers per second. At that rate, it would take billions of years to get there. And long before we arrived, the accelerating expansion of the universe would take over, pushing everything apart faster than gravity can pull it together. Think of the Great Attractor not as a cosmic drain that's sucking us in, but as a gentle current in an enormous cosmic ocean. Yes, we're moving, but we're moving so slowly across such vast distances that the motion is effectively meaningless on human timescales. The Great Attractor is another example of how the galaxy and the larger universe operate on scales that make all motion seem like stillness, all change seem like permanence. Even cosmic structures measuring hundreds of millions of light years across have so much inertia that they might as well be eternal on any timescale relevant to human experience. Here's something about the elemental composition of the galaxy that shows how prepared the universe was for life. The three most common elements in the universe are hydrogen, helium, and oxygen. Hydrogen and helium are primordial created in the Big Bang, but oxygen is created in stars. It takes a star about the mass of our sun, burning for billions of years, then exploding as a supernova to create the oxygen we breathe. Carbon, nitrogen, and other essential elements for life have similar origins. Dr. Anna Frebel's research has shown that it took billions of years of stellar evolution for the galaxy to accumulate enough heavy elements to make planets like Earth possible. By the time our solar system formed 4.6 billion years ago, the galaxy had spent 9 billion years preparing the ingredients. Think of the galaxy as a master chef who spent billions of years gathering ingredients, learning recipes, perfecting techniques. You're not eating a meal that was hastily thrown together. You're experiencing the result of 13 billion years of cosmic preparation. The universe took its time to get everything ready for life, and it didn't cut any corners. The elements in your body are the finest ingredients, refined through billions of years of stellar alchemy, gathered from across the galaxy, concentrated on one perfect planet. You're the result of the universe's patience, its willingness to work on cosmic timescales to create something truly special. Let me share something about the color of starlight and why it's soothing. Different stars emit different colors of light depending on their temperature. Hot stars are blue, medium stars like our sun are yellow, and cool stars are red. When you look at the night sky, you're seeing stars in all these colors, though your eyes aren't sensitive enough to perceive the colors of most stars. But telescopes reveal a night sky that's not black and white. It's a tapestry of colors. Dr. David Malin, a pioneering astrophotographer, spent decades photographing galaxies in color, revealing the beauty hidden in what appears to the naked eye as dim, colorless smudges. His work shows that galaxies aren't cold, sterile places. They're vibrant, colorful, alive with different stellar populations. Think of the galaxy as a cosmic painting where every brushstroke is a star, and the artist has used every color in the palette. You're living inside this masterpiece, surrounded by beauty on a scale that's difficult to comprehend. And the colors aren't random, they tell stories. Blue light means young, hot stars. Red light means old, cool stars. The colors reveal the galaxy's history, its current state, and hints about its future. The universe expresses itself in light, in color, in beauty, and you're surrounded by that expression every clear night when you look up at the sky. Here's something about gravitational stability and Lagrange, points that illustrates how the universe creates pockets of perfect stability. In any two-body gravitational system, like the Sun and Earth, there are 5 special points, called Lagrange points, where the gravitational forces balance out. Objects placed at these points can remain stable with minimal energy expenditure. Dr. Joseph Louis Lagrange discovered these points mathematically in 1772, and we've since used them for spacecraft, like the James Webb Space Telescope, which sits at the L2 point beyond Earth's orbit. But here's the broader point. The universe naturally creates stable locations. Gravity doesn't just pull things together chaotically. It creates structure, pattern, and zones of stability. Think of Lagrange points as cosmic parking spaces, where you can leave something, and it will stay put without any effort. The galaxy is full of these stable configurations, from the orbits of planets to the orbits of stars around the galactic center. Everything seeks stability, everything finds equilibrium, and once equilibrium is reached, systems can persist for billions of years. You're not living in a universe of constant chaos, requiring constant correction. You're living in a universe that naturally settles into stable states, and then maintains those states effortlessly for cosmological timescales. Now let's talk about something philosophers call cosmic humility, and why it's liberating rather than diminishing. When you realize that you're one human among 8 billion, on one planet among trillions in the galaxy, living for a brief moment in a universe that's 13.8 billion years old, you might feel insignificant. But Dr. Rebecca Goldstein, a philosopher and novelist, has written about how this realization can be freeing. When you're small in a vast universe, your mistakes are also small. Your embarrassments are microscopic. Your failures are invisible on cosmic scales. Think of cosmic humility not as a diminishment, but as permission to be imperfect. The universe is so vast that nothing you do can harm it. The galaxy will continue its majestic rotation, whether you succeed or fail at whatever you're attempting. This isn't depressing. It's the ultimate safety net. You can try things, fail, and try again, knowing that the cosmos doesn't judge you, doesn't keep score, doesn't care about your social anxiety or your career setbacks. The galaxy provides a permanent backdrop of stability and indifference that allows you to be fully yourself without cosmic consequences. Your worth isn't determined by the universe. You determine your own worth, and the universe provides a stable stage on which to do so. Here's something about stellar nurseries that shows the galaxy is constantly renewing itself. The Orion Nebula is one of the most active star-forming regions visible from Earth, located about 1,350 light-years away. Within this nebula, hundreds of new stars are forming right now. Dr. Robert Odell, who studied the Orion Nebula using the Hubble Space Telescope, discovered over 150 protoplanetary disks, baby solar systems, in the process of formation. Here's what this means. The galaxy isn't static. It's not a museum of ancient stars slowly dying. It's a living, dynamic system where new stars are constantly being born, new planets are forming, and new opportunities for life are being created. Think of the galaxy as a garden that's always in season. There's always something blooming somewhere. Some stars are being born while others are dying, and this cycle ensures that the galaxy maintains its vitality for trillions of years. You're not living at the end of cosmic history, watching the universe wind down. You're living in the middle of a vibrant, ongoing story of creation and renewal. The galaxy was creating new stars before Earth formed. It's creating new stars now, and it will continue creating new stars long after the sun has died. The process is eternal, or near enough that the difference doesn't matter. Let me tell you about something called the zone of avoidance, and why even cosmic mysteries are comforting. The zone of avoidance is the region of the night sky obscured by the Milky Way's disk. When we look toward the galactic center, we're looking through billions of stars and vast clouds of gas and dust that block our view of anything beyond. For decades, we couldn't see what galaxies existed on the other side of our own galaxy. This sounds frustrating, but here's the beautiful part. Astronomers have now developed techniques using infrared and radio waves that can penetrate the dust, revealing the hidden galaxies beyond. Dr. Renee Cron-Kortwig has spent her career mapping galaxies in the zone of avoidance. Her work shows that even when the universe presents obstacles to understanding, those obstacles can be overcome. Think of cosmic mysteries not as permanent barriers, but as puzzles waiting to be solved. The universe hides its secrets in plain sight, but it doesn't make them impossible to discover. Every mystery, given enough time and clever thinking, yields to human curiosity. You're living in a universe that's complex enough to be interesting, but not so complex that it's incomprehensible. The balance is perfect. Enough mystery to inspire wonder, enough order to allow understanding. The galaxy reveals itself slowly, patiently, rewarding those who look closely and think carefully. Here's something about cosmic rays and Earth's magnetic field that shows how multiple layers of protection surround us. Cosmic rays are high-energy particles from space, mostly protons traveling at nearly the speed of light. If these reached Earth's surface at full strength, they'd be lethal. But as I mentioned earlier, we're protected by multiple shields. The galaxy's magnetic field deflects some cosmic rays. The sun's magnetic field deflects more. Earth's magnetosphere deflects even more, and the atmosphere absorbs the rest. Dr. John Simpson pioneered cosmic ray research in the 1950s, and his work helped reveal this multi-layered protective system. By the time cosmic rays reach the ground, they've been reduced to harmless background radiation, actually less than the radiation you receive from natural radioactive elements in rocks and soil. Think of yourself as living inside a nested set of protective bubbles, like a Russian nesting doll, where each layer provides additional safety. If one layer were to fail, say, if Earth's magnetic field weakened, the other layers would still protect you. The system has redundancy, backup plans, multiple fail-safes. You're not living on a knife's edge, barely protected from cosmic dangers. You're wrapped in layer after layer of natural shielding that's been operating successfully for billions of years. Now let's talk about the concept of look-back time in astronomy and why it gives us perspective on time itself. When you look at a star 100 light years away, you're seeing it as it was 100 years ago. When you look at the Andromeda galaxy, you're seeing it as it was 2.5 million years ago. The farther you look into space, the farther back in time you see. Dr. Edwin Hubble used this principle to discover that the universe is expanding. Distant galaxies appear to be moving away from us, and the farther away they are, the faster they're receding. But here's the comforting part about look-back time. It means the past isn't gone. It's still out there, preserved in light that's traveling through space. The light from Earth is right now spreading outward into the galaxy. In 4.2 years, Light from today will reach Proxima Centauri. In 26,000 years, it will reach the galactic center. Think of light as the universe's memory system. Everything that's ever happened is still happening somewhere, encoded in photons traveling through space. The past isn't lost, it's just distant. This gives time a different quality. Instead of being a linear progression from past to future, time becomes a landscape where past, present, and future all coexist, separated by distance rather than by some unbridgeable temporal gap. When you're lying awake at night, thinking about past mistakes or missed opportunities, remember that those moments still exist out there somewhere, traveling outward at the speed of light, eternally preserved in a cosmic record. Here's something about the principle of mediocrity and why it's actually comforting. The principle of mediocrity, also called the Copernican principle, states that Earth isn't special. We're a typical planet orbiting a typical star in a typical location in a typical galaxy. This sounds deflating until you realize what it means. Everything we observe about our environment is typical. The safety we experience is typical. The stability is typical. The long time scales on which everything operates are typical. If Earth were somehow special or unusual, we'd have to worry that our good fortune might not last. But if we're typical, then the entire galaxy is like this. Safety, stability, and peace aren't rare exceptions. They're the norm. Dr. David Grinspoon has written about this extensively, pointing out that being typical means we can learn about the universe by studying ourselves and our local environment. Think of it like being in a new city and finding out that the neighborhood you're in is typical of the whole city. You don't need to worry that you've lucked into the only safe neighborhood. If where you are is typical, then everywhere is safe. The mediocrity principle transforms from an ego deflation into a security blanket. You're not clinging to a rare island of safety in a dangerous ocean. You're sitting in a typical part of a uniformly safe environment. Let me tell you about the galaxy's rotation period and how it creates cosmic seasons on unimaginably long timescales. As mentioned earlier, one galactic year, one complete orbit around the galactic center, takes about 225 million years. Earth has completed about 20 galactic orbits since it formed. During each orbit, we pass through different regions of the galaxy, through spiral arms where star formation is active, through quieter interarm regions, up and down through the galactic disk. Dr. Nir Shaviv and others have proposed that these transitions might affect Earth's climate over very long timescales, though the effect, if it exists, is subtle. But here's what's beautiful about this concept. The galaxy has rhythms, cycles, and patterns, just like Earth has seasons. But galactic seasons last millions of years. Think of the galaxy as a clock, so large that its hands move imperceptibly slowly. You're living in one frozen moment of galactic time, a moment that will last for millions of years. There's no urgency on galactic scales, no pressure to hurry. The galaxy takes its time with everything, moving through its cycles with patience that makes geological time seem rapid by comparison. When you're feeling rushed, pressured by deadlines and schedules, look up at the night sky and remember, you're part of a system that measures time in units of hundreds of millions of years. The galaxy gives you permission to slow down. Here's something about the ultimate fate of the solar system and why even endings are gentle. In about 5 billion years, the sun will run out of hydrogen fuel and begin fusing helium. It will expand into a red giant, possibly engulfing Earth. This sounds catastrophic, but here's the reality. This process takes millions of years. The sun's luminosity will gradually increase over millions of years, slowly heating Earth. Long before the sun actually engulfs Earth, the oceans will have evaporated, the atmosphere will have been stripped away, and Earth will be uninhabitable. But this gives any future civilization billions of years of warning. Dr. Klaus Peter Schrader has calculated the sun's evolution in detail, and his work shows that even stellar death is a slow, predictable process. Think of the sun's death not as a sudden catastrophe, but as a very slow sunset that takes millions of years to complete. There's time to say goodbye, time to make peace, time to prepare. The galaxy doesn't do sudden. Everything is gradual, everything is predictable, and everything gives you millions of years of advance notice. Even the death of the sun, the most important star in your sky, will be gentle enough that any sufficiently advanced civilization would have ample time to adapt or leave. Now let's talk about something called the habitable epoch of the universe and why we're living in a special time. The universe is about 13.8 billion years old. For the first few billion years, there weren't enough heavy elements to form rocky planets like Earth. In the far future trillions of years from now, star formation will slow and eventually stop as the universe runs out of gas. Dr. Avi Loeb at Harvard has calculated that we're living in the habitable epoch of the universe, the era when stars are forming, heavy elements are abundant, and conditions are right for life. This epoch will last for trillions of years, but we're relatively early in it. Think of the universe as a movie, and you've arrived at the theater just as the opening credits are ending and the main story is beginning. You haven't missed anything important, but you're early enough that the theater is still filling up. The story is just getting interesting, and there's plenty of movie left to enjoy. The best parts of cosmic history might still be ahead. Intelligence and consciousness have only recently emerged in the universe, and we might be among the first civilizations to appear. The galaxy's future could be shaped by beings like us, by choices we and our descendants make. You're not living at the end of something. You're living at the beginning of cosmic consciousness, at the dawn of the universe understanding itself. Here's something about the concept of cosmic time and human time that will help you sleep better. Human psychology is adapted to human timescales: days, seasons, years, maybe decades. We worry about things that operate on these timescales: work, relationships, health, goals. But cosmic processes operate on timescales of millions or billions of years. The two timescales are completely separate. Nothing operating on cosmic timescales can affect your daily life, and nothing in your daily life can affect cosmic processes. Dr. Frank Wilczek, a Nobel laureate in physics, has written about how different timescales create separate realms of causation. Think of it like this. You're a character in a book, and you can interact with other characters and objects within your book. But you can't interact with the printing press that printed the book, or the tree that provided the paper, or the author who wrote the story. Similarly, you exist on human timescales and can affect things on human timescales, but you're completely decoupled from cosmic timescales. The galaxy's evolution will continue regardless of what you do, which means you're free. Free from cosmic responsibility, free from needing to worry about the galaxy's fate, free to focus on the human-scale world where your choices actually matter. The galaxy takes care of itself. You take care of yourself. The two operate independently, and that independence is liberating. Let me share something about the color of the night sky and why darkness itself is beautiful. The night sky is dark, a fact so obvious it seems not worth mentioning. But in 1823, astronomer Heinrich Wilhelm Olbers asked a profound question. If the universe is infinite and filled with stars, why isn't the night sky uniformly bright? Every line of sight should eventually hit a star, making the night sky as bright as the sun. This is called Olbers' paradox. The resolution is that the universe isn't infinitely old. It's only 13.8 billion years old, which means we can only see light from stars within a finite distance. Beyond that distance, light hasn't had time to reach us yet. The darkness of the night sky is proof that the universe has an age and a history. Think about that. Darkness itself tells a story. The dark patches between stars aren't empty failures. They're information. They tell us about the universe's age, about the finite speed of light, about the vast distances between stars. Darkness is as meaningful as light. When you look up at a dark night sky, you're not seeing nothing. You're seeing the edges of observable space. You're seeing the youth of the universe. You're seeing the gaps between star systems that make each point of light precious. Darkness creates context for light. Without darkness, light would mean nothing. The dark night sky is a gift, a cosmic canvas on which the stars paint their stories. Here's something about neutrinos and cosmic invisibility that shows how much is happening that we don't even notice. Trillions of neutrinos from the sun pass through your body every second. They're ghostly particles that barely interact with normal matter. They can pass through the entire Earth as if it weren't there. Dr. Raymond Davis Jr. won the Nobel Prize in 2002 for detecting solar neutrinos, proving that the sun is powered by nuclear fusion. But here's the beautiful part. The universe is full of processes that don't affect us. Neutrinos flood through everything, carrying information about the cosmos, yet they're harmless. Black holes exist, but can't reach us. Gamma rays from distant explosions wash over us, but are absorbed by the atmosphere. The universe is full of activity, but most of it doesn't touch us. Think of yourself as living inside a peaceful room while outside the universe conducts its business. The walls between you and cosmic violence are thick. The universe keeps its dangerous processes at a distance, allowing only the gentle, beautiful parts starlight, the slow drift of galaxies, the patient rotation of the cosmos to reach you. You're not constantly under threat from cosmic forces. You're insulated, protected, allowed to exist in peace while the universe's more violent processes happen far away or pass through you harmlessly. Now let's talk about the concept of cosmic distance ladder and why the universe is knowable. To measure distances in space, astronomers use a series of techniques, each building on the previous one. For nearby objects, we use parallax, the apparent shift in position when viewed from different locations. For more distant objects, we use variable stars whose brightness cycles predictably. For even more distant objects, we use supernova as standard candles of known brightness. Dr. Wendy Friedman has spent her career refining the cosmic distance ladder, allowing us to measure distances to the farthest galaxies. Here's why this matters. The universe reveals itself to us. It's not opaque or incomprehensible. With careful observation and clever thinking, we can measure how far away things are, how old they are, what they're made of, and how they're moving. Think of the universe as a textbook that's willing to teach you. It doesn't hide its secrets maliciously. Every mystery has clues. Every question has an answer if you look carefully enough. The galaxy isn't a confusing chaos. It's an elegant system that follows rules, and those rules are discoverable. You live in a universe that makes sense, that follows patterns, that rewards curiosity with understanding. That's perhaps the most comforting fact of all. The cosmos is comprehensible. Here's something about the cosmic web structure and why it shows intentionality in the universes. Structure, not intentionality from a designer, but intentionality in the sense of having clear organizational principles. Computer simulations of structure formation in the universe, starting from the nearly smooth conditions after the Big Bang and evolving forward using only gravity and dark matter, naturally produce the cosmic web we observe. Filaments of galaxies separated by vast voids. Dr. Volker Springel created some of the most detailed simulations, called the Millennium Simulation, and its successors. These simulations show that the structure we see isn't accidental. It's inevitable given the initial conditions and the laws of physics. Think of the cosmic web as a sculpture that creates itself. Given the raw materials and the laws of nature, the universe naturally organizes itself into the beautiful, intricate structure we observe. There's no sculptor, but there's sculptural intention built into the laws themselves. The galaxy isn't a random accident. It's an inevitable outcome of cosmic evolution. You're not living in a universe that could have easily gone wrong. You're living in a universe where getting things right is the natural, inevitable outcome of physical law. Let me tell you about cosmic humility and cosmic confidence existing simultaneously. Yes, you're small compared to the galaxy, but you're also the only thing in the galaxy that we know can understand galaxies. Rocks don't comprehend cosmic structure. Stars don't ponder their place in the universe, but you do. In a very real sense, you're the galaxy's way of knowing itself, as Carl Sagan famously said. Dr. Joel Primack and Nancy Abrams wrote a book called The View from the Center of the Universe that explores this idea. Humans aren't at the center of the universe spatially, but we are at the center of the size scale. On a logarithmic scale from the smallest things, Planck length, to the largest, the observable universe, humans sit right in the middle. We're also at the middle of the complexity scale simpler than ecosystems and societies, more complex than atoms and molecules. Think of yourself not as an insignificant speck in a vast cosmos, but as the bridge between the very small and the very large, between simplicity and complexity, between matter and meaning. The galaxy needs consciousness to be fully realized. Without observers, the beauty of spiral arms is wasted. The elegance of orbital mechanics goes unappreciated. The story of cosmic evolution remains untold. You're small, but you're essential. The galaxy has spent 13 billion years creating you. That's not insignificant. That's the opposite of insignificant. Here's our final fact, the one to hold on to as you drift off to sleep. The universe is currently in its most stable, peaceful, beautiful era. The violent chaos of the Big Bang is long past. The far future heat death is inconceivably far away. Right now, in this cosmic moment that's lasting for trillions of years, the universe is in its prime. Stars are shining, galaxies are gracefully rotating, planets are orbiting peacefully. And on at least one of those planets, conscious beings have emerged who can look up at the sky and understand what they're seeing. You live in a universe that's vast enough to humble you, yet comprehensible enough to understand. You live in a galaxy that's ancient enough to be stable, yet young enough to still be creating new stars. You live on a planet that's perfectly positioned in the habitable zone of a perfectly stable star in the perfectly calm region of a perfectly organized galaxy. And every night, when you lie down to sleep, you're cradled by gravity, the gentlest force in the universe, the force that holds everything together, that maintains every orbit, that keeps the galaxy spinning smoothly, that has never once failed in its duty of holding the cosmos in its careful embrace. The galaxy is your home, and it's been safely home to Earth for 4.6 billion years. Sleep well, knowing that tonight, tomorrow night, and every night for billions of years to come, the galaxy will continue its peaceful rotation, the stars will continue their gentle shine, and the cosmos will continue its patient evolution. You're safe. Your home and the universe itself is your lullaby. Good night.